Thank you, Ida. I think I'm live now. And also thanks, Tom, to your talk about Packer. And yes, live demos are always tricky. I don't have them for my talk, which I'm glad about. Yes, I'll be talking about the ups and downs of maintaining the Terraform Docker provider. And this talk is going to be no demo. And if there are any questions, please write them in the chat. I have the chat open next to me. I'm not sure if I can see the chat and hold my talk at the same time. Maybe we'll have some time afterwards for some Q&A session, and that would be great. So over a year ago, I was working for a client project because I'm a cloud consultant and I used AWS, and they wanted to implement some resources in Terraform. And so we went ahead to the documentation, saw cool, CloudFormation stack sets, they are already supported by the Terraform provider. So we went ahead, did the implementation, we run Terraform plan, it looked fine, and then we run Terraform apply, and we run into an error. It didn't work out. We tried different things. Maybe we did set some attributes wrong, tried out true, false, enabled, disabled, didn't work, always at the same error. So I found a bug in Terraform, what I'm going to do now. And and we are all good developers, so what we always do is we go to GitHub and we open issue. But in this case, we see, okay, there are almost 4,000 open issues, and also many open pull requests. How can that be? And as I already said, I'm also the maintainer of the Docker Terraform provider. And so I can give you some insights into how the process looks like, how maintenance works, how the development works of a provider. And as Hila also introduced me, I'm also a senior cloud consultant. And when I'm not busy with open source and Terraform and so on, I'm mostly working with AWS and Terraform and also CDK. So in the next roughly 25 minutes, I'll be talking about how to develop a provider, what the main issues are, what the main pain points are, also about testing and CI/CD, and this will be basically about testing and CI/CD best practices, because the best practices can also be applied for testing a Terraform provider. And then also, as a last point, feature development, how we choose features, how we choose issues, how we tackle bugs, and so on. The first question I want to answer is why? Why do we need a Docker provider? And the answer is quite easy, because not everyone is working with EKS, GKE, ECS, and all this managed Kubernetes or Docker services. And many companies and many developers are still using on-premise machines, are using data centers. But they also want to be able to deploy Docker containers using Terraform, using infrastructure as code. And that's why this provider was actually implemented and brought into life. And the first commit was in 2015, so almost 8 years ago, which is a long time, I think, from my perspective, because I'm still quite young. And I think it's always interesting to take a look at the commit message, and the first commit is always initial commit. It's also, for my personal projects, it's always initial commit, adding something. And also the commit message is a bit longer here, and it also contains the text, unit tests do not exist yet. So I can speak from my own experience. My first commit also, they are always messaged initial commit, and they rarely have tests. Although we all know better, they don't have tests in the initial commit. Since then, there are 728 commits. Actually, of today, it's 29 because I just merged the PR last hour. And the Docker provider was introduced by HashiCorp first. And since roughly 2 years, we at Kreuzwerker took over the ownership and are maintaining it. So let's further deep dive into how to develop a provider. The first thing that needs to be addressed when writing a provider is understanding Terraform state and how to fit the resources that we want to create and manage into the state. So as we all know, a really rough idea of the Terraform state is to map the real world into a configuration. And whenever those things don't match, then a Terraform plan or apply will have changes. And the issue is, in that case, that Docker run itself adds some abstractions on the notion of, okay, I want to run this Docker container. Of course, in the end, we're going to have a running or stop container, but there are many facets to that, because, of course, the easiest case is a normal container. It's our web server, it's our database. We just say, okay, please run it. We write the according Terraform configuration, and then if for some reason the container stops or fails, on the next plan apply, there's a diff and it's being started again. Now there's more things that come into place. I call them setup containers. People often like to use for an initial setup of a Kubernetes cluster or of a Docker Swarm, those setup containers to just set up things, and they are spun up once, they're running for a few seconds, for a few minutes, and then it's done. But we don't have the configuration for that, because when the next time we were to run Terraform plan or apply, would say, okay, this container is missing, I want to spin it up, but actually we don't want to spin it up. So in Terraform, in the configuration, we need to add different attributes in order to further distinguish what the developer wants to do with this container. Waiting time, spin-up time, health checks, and so on and so on. And timeouts, especially for image ports, because although the best practice is to have small containers and small images, there are still images being pulled with 5 gigabytes or 10 gigabytes. And so all of this is basically in contrast to, okay, I want to have a clear and a really simple Terraform HCL configuration. And we have to map all the different use cases to attributes in the Terraform configuration, so the Terraform knows, okay, what is actually going on with these containers. And what we do is quite simple, although it's not really simple. When I was using a Docker on bare metal machines and I spun up containers, I always watched Docker inspect and see, okay, it's up at some point in time. After a few seconds, after 2 minutes, I see the health check, the status, and so on. And it's actually the same thing we do inside the Docker provider. We pull the Docker daemon every 2 seconds or every second and ask, hey, what is actually the status of the container? And then we try to map, okay, what is the response of the Docker daemon with the attributes we were given by the developer. Active codes, timeouts, health checks, is it a one-time setup or not, and so on. And this code is quite complex because there are many, many different possibilities and states to consider to have, in the end, okay, plan is good or there's a diff. I mentioned the term Docker daemon quite a few times already. So the Docker daemon is basically our backend. We are talking to the Docker daemon to create all the resources, our images, our containers, our volumes, networks, you name it. So our client is our provider, is our Docker provider we are writing. How do those two things communicate. Of course, we could use curl and simply curl, or in any programming language, talk to the API of the Docker daemon. But we wouldn't be programmers if we were to do that. There's actually a client package published by Docker. It's a Golang package, and it's a wrapper around the API. So you can use this package in order to talk to the Docker daemon, to inspect containers, to list containers, and so on and so on. And the issue is there as well, the Docker daemon has different versions. There are releases, there are different releases, there are features, there are bug fixes, and so on. And for example, the GPU support for using GPUs in containers was introduced in version 1.41. And we also introduced that in our client. And so if you were to use this attribute in the provider, in the client, but the Docker daemon is not on the newest version, we have to actually tell the developer, sorry, it doesn't work. So we have to check for the API version of the Docker daemon. Okay, does it support all the things that we want to use? Another example is build-kit support, or build-x plugins and so on. So we constantly, when using the daemon and when communicating, we constantly have to check, okay, are all the dependencies there? Are all the things enabled or disabled? And this is actually weird. In implementing all this, we're actually doing the work the Docker CLI has already done, because when you're using the Docker CLI and using a Docker run, it does all of that as well. So one might ask, why don't you use the Docker CLI to talk to the Docker daemon? So why don't we wrap the Docker CLI and use all the implementation the Docker CLI already has done to talk to the daemon, and then we would be good. It's not that easy. And I'm saying that I think many times in this presentation, because it, of course, it always depends. So here's a small comparison. So when using the client package, we of course have to re-implement the CLI code. It's not a copy-paste because some things we don't need from the CLI, but often when we are implementing support on the features, we of course take a look at the Docker CLI code and see what they are doing. When wrapping the Docker CLI, we don't need any re-implementation, of course, because it's already there, the code. And this is also the advantage of using the client package, because we don't have the dependency on the Docker CLI wherever we run. And this is also the disadvantage of wrapping the CLI. We need the CLI to be installed. It's not a problem on local machines, on dev machines most of the time, but it's a problem for CI/CD machines, for Terraform Cloud, because there it's much more difficult to install binary or to get even installed or signed off by security department, for example. And in both cases, we also need mappers. And what do I mean by that? The Docker daemon, whenever we ask, okay, please give us all the container information, it responds with JSON, array and objects. However, on the Terraform side, on the provider implementation side, there are sets, lists, and maps. So we have a variety in data types than we get from the Docker daemon, and we always have to map the data and remap. And so, as an example, for the Docker service resource, we have around 1,000 lines of code to just map different objects and types throughout all the process. And the client package, when we use that, we have better control of what we're doing, which means a better performance as well, and we can really choose, okay, which endpoints are we talking to, which data are we getting. The second thing when implementing and maintaining a provider is, I call it rushed decisions. That can annoy you really on the long run, and it's mostly about implementing new features and also implementing new features without a lot of testing, and also without really questioning if they fit into the scope or if the code is correct. For a long time, we did have a Docker image resource, which was responsible for building a Docker image locally, but it couldn't push the image to a registry, for example, got a Docker Hub or ECR. And then someone filed a PR, which introduced a Docker registry image, which was great because now we did then have the possibility to also push an image to a registry. The thing is that this PR also introduced a second build implementation for the Docker registry image. So now we did have two build implementations, which is not that good because you have to maintain two implementations. You can introduce bugs on two places, and you always want to have, especially for those core components, you want to have everything in one place. And the second issue is, I mentioned the word bugs. This build implementation also had a few small bugs, which resulted in issues in our GitHub repository. For example, the goal was that whenever a file on your Docker build context changes, that the Docker image is being rebuilt, which is amazing, which is really cool because that's what you want. When your source files change, you want to have the image being rebuilt. There were a few problems with that. The one thing is that it didn't really take into account Windows paths. So the path building and path matching and hashing of the directory was a bit not really good. And this second issue was that there were many issues with provider-produced inconsistent finder plan, which came from the fact that those two values differed, and those two values, you see the long hash sums, they were hash sums of the directory, and in this case of the current directory. And in the current directory, of course, there are also the Terraform state files, for example, or package log files and so on. And so whenever a Terraform plan and a file was run, of course, the state files change. So of course, the hash of the whole directory changed. What we did over the course of a few months, that we basically merged the two build implementations together, so that we now have only one build implementation, and the Docker image resource is now only responsible for building an image, and the Docker registry resource is responsible for pushing an image to a registry. The next part is about CI/CD, which in our case is luckily quite easy because we have the client and the server on the same machine. We don't need to mock anything because our server is a Docker daemon. We can simply install that on our GitHub Actions runners, and I think they're already pre-installed. So we don't need to have any communication between machines here, which is quite nice. And we have three other dependencies. We also need local registries in order to test the pulling of and pushing of images, because we have the Docker registry image resource. So we need an HTTPS registry, and then we also test with insecure HTTPS, because many corporates are still using internal registries signed with self-signed certificates and so on. And then we also have tests for HTTP registries. One thing that we also noticed last year, our tests were taking a long time. We had all of our test suite in one job, and it was taking 40 minutes, which is way too long. And this is not good for fast feedbacks. And imagine opening PR and you wait 15 minutes until you get feedback. So yes, we had to change something. And the good thing is that all the tests in our provider are prefixed with the resource the tests are for. So we could simply tell go test, please run only the tests for the Docker container or only the tests for the Docker image. And then we converted that to a matrix in Terraform. And now we have, for every PR, we have 20 jobs running in parallel, which test every resource independent. And we also test for 2 different Terraform versions. And as you can see, that brought down the total time to still quite a long 9 minutes. The longest is still the Docker service, which is around 7 minutes. We might even split that further up into multiple smaller jobs so that we bring the duration down to 4 or 5 minutes. But still, now it's quite good because if there's a test failing in the Docker tag resource, you get a really fast feedback what's going on. And the advantage of having fast tests and fast feedback loops is also that you have a new friend called Renovate or Dependabot or Snyk. There are many players on the market now, and which is nice because, as I said this morning, I just merged a PR, which was from Renovate, and I saw all the tests are green, amazing. I can just approve and merge. And fun fact, Renovate is the second and fourth biggest contributor in terms of a number of commits. I'm on 3rd place, and a colleague of mine, also from Kreuzwerker, is on 1st place. And you can also see for the 1st place and also the 5th place there, they have changed quite many lines of code. And this is because in the earlier days, there were also Golang dependencies and 2 dependencies checked in, and changing that always led to huge changes in lines of code. My last point is about new features. I kind of teased that in the beginning, and we do have 2 highly requested features, and I'm always counting them by the number of thumbs up on the issue. It's support for Podman and also support for Docker Compose. And I kind of want to elaborate on our thought process on when we do implement new requested features. And yeah. And mostly for bugs, the process is different because for bugs, the code implementation is already there. In many cases, we just need to add a test, which basically test the bug as a regression test and then fix a few lines of code. So when you filter the closed issues also by thumbs up count, you can also get many highly upvoted issues, but we close them because fixing bugs is of course most of the time easier than introducing any features, especially highly requested features. Because for those features, I try to come up with a nice triangle and 2 categories, which are basically what we always take a look at and take into account. The first category is usefulness of the feature. And yes, especially in the case of support for Podman, support for Docker Compose, of course, it's useful for the users to have that, to be able to use Podman, to get rid of Docker, especially with the license changes now and so on. The second category is implementation complexity, which in those two cases is really high, especially if you're Docker Compose. For Podman, I'm going to get into a few more details in a sec. And another category is, are we able to support that feature? Are we able to provide support, provide help, answer issues, and so on? In the case of Podman says it's simply put in alias Docker. And I did that on my local machine for the tests. I opened the PR or opened a branch. I tried that, it didn't work. I had to change a few things because, of course, on testing it's a bit more complicated. We do have our 10 resources. 3 of them are not supported in Podman because they are more of a Docker service thing. In 5 resources, many tests failed. For some reasons, I didn't really go further into that yet. And 2 resources, they say, okay, all tests passed on the first run. And that shows me that simply supporting Podman is not that easy because there are still tests failing. We would have to fix those tests, add additional implementation because, of course, Podman and Docker, they both say, okay, we can run OCI container images, but still behind the scenes, they're doing maybe a few things differently. Maybe Docker has more features or supports more features than Podman and so on. So bringing those 2 under this at the same hood might be really complex. So we're probably going to decide to unofficially support Podman to say, okay, many people are using Podman with the Docker Terraform provider, but we won't provide any help or official support. So to sum it up, I'm almost at the end of my talk. I talked about how developing a provider works, how to get resources and state into sync so that you don't have unexpected diffs and changes on Terraform, plan and apply. I also talked a bit about this CI/CD and testing, and there it's really just applying the best practices of any CI/CD pipeline, splitting tests up, making them small, making them fast. And then I also talked a bit about feature development and how we decide about what we're going to implement. So what's actually the motivation of me and my colleagues to maintain this provider? And to be honest, we seldomly receive feedback from users. So I went through the repository, and in the past half year roughly, I managed to find 3 thumbs up or comments. There might be a few more, but that's it. And in Germany, there's actually a saying, and it's actually a saying from a German dialect, that if no one says anything or complains about anything, that is already enough praise. And there's actually some truth in there, because if no one opens an issue, it means that there are actually no noticeable bugs, or that actually no one is using the provider, which I don't think. And to be fair, my motivation is mostly comes from the curiosity to play around with the involved technologies. So if you want to play around with Docker and Golang or also Terraform, feel free to open issues, open PRs, take a look at that, contact us, and get in contact, and we would be glad to see new faces in the commit messages and commit names. Thank you.